continuing from yesterday, we talked about the EIGRP metric and how we calculate the metric, and he said that you would determine the bandwidth by dividing 10 to the power 7 by the actual bandwidth. Well, when I say actual bandwidth, this is the bandwidth command. It's not the real speed of your link, physical speed of your link. The bandwidth on all serial interfaces has a default, Cisco serial interfaces, which is equal to a T1 link, which is 1,544 kilobits per second or 1.544 megabits per second. For Ethernet, it has also a predetermined cost. For fast Ethernet, for gigabit Ethernet, so there's a relationship between the cost and the bandwidth. To calculate the cost, in general, the concept of a cost is just the bandwidth relationship to the cost. So the higher the bandwidth, the lower the cost. The lower the bandwidth, the higher the cost. And therefore, the lower the bandwidth, the higher the cost, means the higher the metric. And we don't like higher metrics. We prefer the metric to be as low as possible. Whereas the delay, we add all of the delays together from source destination for all of the links, and then we need to divide them by 10. Why do you need to divide them by 10? Anybody remembers what we said yesterday?
Because of the figure becomes all about the hops, and we get like 10 because it's we subtract them. Not hops.
They need to be in blocks of 10 microseconds, in blocks. Okay, so we divide them by 10. That's the reason. Whereas the bandwidth we use in our calculation, is it the slowest bandwidth along the way or the fastest bandwidth along the way? The slowest bandwidth. And then we need to multiply the whole thing by 256 to give us the EIGRP metric. If you don't multiply by 256, we'll actually be calculating the EIGRP metric, not the EIGRP metric. Excellent. And this, as we could see here, this metric that we calculate is the second figure we see inside the brackets of your show IP route output. The first number is your admin distance, and the second number is your metric. Now, this same metric, we can also see it when we do which command? Remember which command? Which can also see? Which command? Which show command? Yeah. Topology. Thank you. Well done. Topology. Show IP EIGRP topology will also show you. And the show IP EIGRP topology for every destination network, you will have two numbers inside the brackets. The first number is the metric, and the second number we called it what? Do you remember what we called it? The reported distance. The reported distance, yeah, or the advertised distance. This is what my neighbor. So, for example, for me to get to Mansour, my metric is let's say 100. It's an easy number. Normally, the numbers with the EIGRP is like in the millions or thousands at least. So let's say it's 100. Now, and my metric to Muhammad here, it's 50. Now, so or rather, going to Mansour via Muhammad is 50. Via Rashid, it's 100. Now, which one do I put in my routing table? Muhammad, because it's lower metric. Okay. Now, how did I get the 50? How did I get the 100? Well, basically, because I need to connect to Rashid to get to Mansour. I need to connect to Muhammad before I can get to Mansour. So my overall, my composite metric, the total metric, is actually made from those two links. Now, Rashid may say to me, look, I can get you to Mansour with a metric of only 20. So this is what you're advertising. This is your advertising or reported distance. Whereas Muhammad can say, I can get you there with a metric of 40. Hold it. 40 is bigger than what you just said. You said 20? Yeah? Why did I choose? How come then the overall became 50 via Muhammad and the overall became 100 via Rashid? Well, that's to do with my link to each of you. Because it could be my link to Rashid is only a 64 kilobits per second, very low link, low speed link. Whereas my link to Muhammad is so fast that the actual distance, the feasible distance between me to him, or my metric between me and Muhammad is only 10. It's only 10. So the total will be from me to him is 10. From Muhammad to Mansour, he's advertising to me, said, I can get you there with 40. So he can have either direct connection or there may be other routers between him and Mansour. I don't care. From my point of view, I don't care. All I care is about this is what he's reporting to me. Says, I can get you to this destination, to Mansour, with a metric of 40. Me to him is 10. 10 plus 40, 50. Whereas you told me, Rashid, that you can get me to Mansour. And also, you could either have a direct connection to Mansour or you could have there multiple routers between you, between you and Mansour. But I don't care about that. All I know is that you're telling me I can get you there. Your reported distance, you're reporting to me. You're advertising to me. That's why it's called reported or advertised distance. You're telling me I can get you there with 20. But from me to you, it's 80. So for me to get to Mansour via Rashid, it's 80 plus 20. What is it? 100. So this is where the 100 comes from. And this is why I chose Muhammad's path. I preferred him to reach Mansour rather than choosing Rashid's path to reach Mansour. Okay? Then we'll come to some concepts about dual, which will tell us, remember we explained earlier, we talked about EIGRP as allowing us load balancing. And we said EIGRP is the only protocol that allows not only equal cost load balancing, but it also allows unequal cost. Now, very quickly, can anybody just remind us what is equal cost? What does equal cost mean? Yeah.
The speed from this the other RT should be the same. This is equal.
The speed or the metric? The metric.
Yeah.
So I can get to Mansour via Rashid with a metric of 50. I can get to Mansour via Muhammad, also metric of 50. So both of you are 50. Both of you are 50. I will load balance. One packet I will send via Rashid, another packet I will send via Muhammad. For me, it's equal cost. So I can load balance between the two. This way, not a single link will be busier than any other link. They all have a share of the load. Now, by default, I can do equal cost balancing for up to 4 by default, without any issues. Up to 4, I can. If I want to increase it more than 4, I need to modify the equal cost balancing, load balancing metric, and I can actually load balance up to 16. Up to 16 paths, equal. If they're all equal. Okay, so I go one packet, 1, 2, 6, then I go back again, one packet, like that. Okay, so I can load balance between them. However, what if one of them is 50? Let's say by Muhammad is 50. What about then the path through Rashid? It's 100. Can I use both? They're not equal. But this is what EIGRP says. EIGRP says, hey, I can actually do load balancing between unequal costs. But there's a but, of course, in the issue. There's a condition you have to meet. What is the condition? The condition, we call it the feasibility condition. You know what feasible is? Can it be done? The word feasible. Is it feasible? When we say, is it feasible for you to complete this assignment in 1 hour? يعني ممكن. الإمكانية. Feasibility and الإمكانية. Is it feasible or not? So you have to do some test. What is the test? The test says that the reported distance from Rashid, if it is less, cannot be equal, cannot be more, must be less than the feasible distance. The feasible distance is another name for the metric. So when you say the metric, you know that name in the show IP route, that number that comes out the admin distance, which we call the metric, is also called the feasible distance. It's also called feasible distance. Now, if your reported distance, which is, let's say 20, you're reporting to me 20, is less than my feasible distance, which is what? Was 50. To go by Muhammad is 50. Is 20 less than 50?
Yes.
It is. So you've met the condition. You have met the feasibility condition. It means I can mark you as a backup route. A backup route, we call it a feasible successor, as opposed to the best route, which is called the successor. So Muhammad, for me, he's my successor router. He's my successor. Why? Because he's providing the best path to this particular destination. In this case, destination is Mansour. So he's getting me to Mansour with the best possible metric. So he is my successor. So the word successor defines the neighboring router, which gives me the best path to the destination. The best one. The one with the least cost. Whereas Rashid, he is providing me a backup route. Now a backup route is called what? The feasible successor. The backup route normally will not come into effect. It will be there in the topology table. It will be shown in the topology table, but it will not be shown where? In the routing table. Because what's the job of the routing table? What do we see there? Only the best path. Only best path. Now, if we have equal best path, 2, 3, 4 of them, 5 of them, up to 16, they will all show on the routing table. All of them. If they're all equal. But if they're unequal, only the one with the lowest metric will show on the routing table. Only one the lowest. So only Muhammad's route will show. So I will have network destination Mansour in brackets admin distance 90/50, because this is my feasible distance to Mansour 50 via, and I said via what? Via Muhammad. He's my next hop. Will I see your route? No, I don't see it unless I do what? I need to tweak, okay, the load balancing parameter that will allow me to say not only when the costs are equal, I will use them, but I can also actually make it possible so that even if the backup route, the feasible successor route, is within a certain range, twice, 3 times, 4 times of my successor route, within that range, if it falls within that range, as well as it meets the feasibility condition, meaning what? The advertised distance is less than my feasible distance or the metric, only then I will also see it where? It will show in the routing table as well. So both of them will show in the routing table. Okay? And we'll come to that a bit later when we talk about unequal load balancing. So as you can see here, we have some certain concepts that we need to understand. This metric that we see, which follows the admin distance, we call it the feasible distance. So another name for our metric is feasible distance. Via, whose IP address is this? This is my neighbor, my next hop, my neighbor. This is Muhammad. We call him the successor. We call him successor because he provides the best path to the destination. Okay, good. So let's just go over it. So feasible successor is what we call the backup route. So in this case, it was Rashid who was a feasible successor. However, he can only be a feasible successor if he does what? If he satisfies the feasibility condition. Now, what's the feasibility condition? What did we say?
It should be less than
If his reported distance is less than my feasible distance, he's okay. But let's say his reported distance was 50. My feasible distance is 50. Via Muhammad, it's 50 to Mansour. Yeah? But he's reporting to me 50. 50, is that equal or less? It's equal. It will not work.
Should be less or
Should be less. Equal is not good enough. If it's 50 or higher, so it's 50, 51, 60, 100, whatever his report is, if it is equal or greater than the feasible distance, my best metric to the destination, I do not trust him. Why is this? Sometimes actually there's no problem with it, but EIGRP is very paranoid. Really is paranoid. It's really it cannot stand loops, routing loops. So it says, in general, if the reported distance is equal or greater than the feasible distance, it thinks there's a possibility that actually Rashid is coming through me before he's getting to Mansour. There is this possibility. And if he's coming through me to reach to Mansour, then this will create what? A routing loop. This will be a routing loop. So the packets will circulate between me, Mansour, and Rashid, Mansour, me, and it will circulate. So it says, okay, let's not take any chances. No chances whatsoever. So they made this feasibility condition so tough that there will never be a chance of a routing loop. So if his reported distance is less than the feasible distance, according to the test that was done, according to the algorithm, to the dual and all the calculations and a lot of the research that was done in this topic, they said as long as his reported distance is less than the feasible distance, there is no chance that there will be a routing loop. No chance. So rather than take any chances, because sometimes they may not be, he's not coming through me, he's just genuinely, he's taking me there directly to Mansour, but with an equal or greater reported distance on my feasible distance. He's not coming through me. But EIGRP routers don't know this. They have to have a general condition which will meet all. They cannot have one condition for one, another condition for another. So they made one condition which is quite tough. Okay. Right, so if you look at now the topology table, and this is what we did yesterday in Packet Tracer, topology table. So notice there's a letter P. Anybody remember what the P stands for? P? Passive, thank you. What does it mean passive? Is good or bad?
No, passive is when you like no, it's when a neighbor router or interface, it's there, but you don't get any updates. But it's not like it's not active.
You know, normally passive would mean that, wouldn't you? Because passive normally we use the word passive in a how do you say, in a bad way? Yeah. Passive.
So this,
but here passive means what?
This shortens up all the IPs together. Shows you the group of IPs.
No, that's the summary, not passive. You're thinking about summaries. No, passive actually for EIGRP, when you see the word passive in the EIGRP topology, is actually good. Passive means there is no activity on this path. No activity means what? It's stable. This path has been stable, has not gone up or down, has not been disconnected. It did, okay? There's no problem with it. Exactly. Passive means this is a reliable path to this particular destination. You should be worried if you see the word A instead of P. A means active. If it's active, you shouldn't actually, because active, any network, any reference to any network in the EIGRP topology, if it goes active, it should not be in this state for more than a few milliseconds. If it stays more than that, something is seriously wrong in your network topology. Active means dual algorithm is actively seeking an alternative path to this destination. Why? Because its existing path suddenly disappeared. So, for example, I have two paths to Mansour, one via Muhammad, one via Rashid. Let's go back again. Something goes wrong in the link between me and Muhammad. Disconnected, or Muhammad, he switches off his services. No more. For this split second, in milliseconds, the dual says, I've lost Muhammad. Do I have a backup? He says, yeah, I have a backup. Because there is the route via Rashid is called a feasible successor. So it does not need to go active. It stays passive. Immediately, however, it replaces the path I had to Mansour via Muhammad, replaces with the path via Rashid. But what if I didn't have Rashid as a backup, as a feasible successor? It checks the topology table, says I only had one path. So I need to go to active now. So it goes to active, and then it sends a multicast message, a query. Remember the query we had query, update, reply, acknowledgement, and all of that. Those the EIGRP packets. It sends a query out of all of its interfaces to all of its neighbors. Please, can anybody help me? Can someone tell me if you have an alternative path to Mansour? If someone has this path, they will reply, and I immediately go from active back to passive. And I install their path in my topology table, and then if it is the best one, in the routing table. However, what if nobody replies? Or the reply comes back negative? Then immediately it removes it from the routing table. Removes this path, this network, Mansour, removes it from my topology table as well. I already lost it from the routing table, but it stayed for a few extra milliseconds in the topology table. So his path, the path to Mansour's network, stayed there for an extra few milliseconds until I try to find an alternative path to him. But if I couldn't, then it removes him also from the topology table. Okay? Right. Now, let's have a look here. What is this telling you? What is this slide telling you?
Shows you all the topology there.
Let's have a look at the first. It's passive, means I have a stable path taking me to a network destination 192.168.1.0. It says it has one successor. So am I doing load balancing? No load balancing. I have only one successor to reach this destination, to reach 192.168.1.0. The feasible distance. What is another name for the feasible distance? The metric. It's 2170112. This same number, I find it here, which is the feasible distance is the same number and the first number inside the brackets. And it says via my, okay, serial. Now, what is the second one? Why do I have two? Why do I have two? This is very similar to the situation I was talking about. Let's say Mansour is 192.168.1.0. Let's say Mansour, this is Mansour. So it says in order to get to Mansour, I can get to him via Muhammad, which is via neighbor 192.168.10.6, or I can get to him via Rashid, and he's 172.16.3.2. Now, if I go to him via Muhammad, my feasible distance is 2170112, and Muhammad is reporting to me his distance to Mansour is 2816. And I get to Muhammad via my serial 00 interface, sorry, 001 interface. Now, the second one, it says via neighbor Rashid, which is 170.16.3.2, because this is his IP address. And he will take me to Mansour using a feasible distance, or a metric, not a feasible distance, a metric of 4,100,000, and I don't know, it was 41 million, sorry, 41 million something, 240,000, 256. Big number. Yeah. Obviously, he cannot be my successor. Why? Because this number is much bigger than this. So this is what? This is 2 million, 2.1 million. This is 41 million. So immediately Muhammad is recognized as my feasible, as my successor, and he gives me the feasible distance through him. But look at this number, the second number. Rashid is reporting to me. He said, I can get you to 192.168.1.0, which is Mansour, with a reported distance. See, it says reported distance. His reported distance is what? It's 3,012,096. 3,012,096. And and this is offered to me via my own serial 00 interface to reach Rashid. Now, the question is, does Rashid qualify as a feasible successor?
No.
Why?
Because it's much higher than Muhammad.
Much higher than which number? What are you comparing?
2000.
You're comparing the reported distance between yours and the physical distance you have.
Exactly. Well done, Muhammad. So I'm comparing the reported distance. So Rashid's reported distance, which is 3,012,000. I'm comparing it to the feasible, not to this 2,800. I'm comparing it to the feasible distance, which is 2,170,000. Obviously, 3 million is bigger than 2 million. What did we say? We say for Rashid to become a feasible successor, a backup route, it should be less. It cannot even be equal, but it's more. Therefore, what does the title says? No feasible successor. That's why I said, in this particular example, I don't have a backup route. There is no feasible successor. Now, Dual works as a finite state machine. What does it mean, finite state machine? It's like it's a logical, it's a set of logic, which is reads inputs, and based on the value of the input, it can only have a set of outputs, predefined set of outputs. I'm not going to go through all of it very quickly. So this is what happens when, for example, I lose connectivity to my successor, to Muhammad. When I lose connectivity to Muhammad, immediately Dual will ask itself, do I have a feasible successor?
Yes.
If the answer is yes, immediately promote Rashid to a successor and put him in my routing table, and that's it. Do I have a new feasible successor or not? If nothing, I don't have another new feasible successor. Otherwise, everything goes very smoothly and no problem. But what if I don't have a feasible successor? If I know here, place the destination in active. You see, when do we go to active? When I don't have feasible successor. Now, in active, I send a query, which is a multicast message, sent to 224.0.0.9. Yeah, I send it to all of my neighbors. Now, if one of my neighbors reply with a yes, they have, then I will select a new successor. But if they say no, I remove that destination from the routing table. This is what I just explained to you. Okay. We can actually we can debug can use debugging to see what's happening inside the finite state machine, the EIGRP finite state machine. And whenever you can simulate a problem by shutting down interfaces and doing an O shutdown. When it shutdowns, immediately says feasible successor is this. I want to remove destination because I didn't find any alternative, and so on. See, this is the kind of things, the messages, the syslog messages that come back to you. Show IP route. Okay. In this particular case, I did have a feasible successor. So now it's gone to this new feasible successor. It changed from 192.168 10.6. It was Muhammad 10.6. It changed to 172.16 3.1. 3.1. Right. Okay. So comparison between EIGRP version 4, version 6. I'm not going to do this comparison. Okay. So let's have a break. And after the break, gentlemen, we will start chapter 5. I'm just going to concentrate on the summary route for chapter 5. Okay. Have a break, guys. Thank you. Right, gentlemen, we'll continue now with a couple of concepts remaining on especially summarization in chapter 5, which is required for your exams, for your projects, etc. Right, so this is just a reminder, this is the network topology that we have, and which is also shown here in this. Remember, this is the packet tracer example that we had, which reflects this is the teaching topology that we have here. Now, we understand that by default, EIGRP will automatically summarize, correct? So if you had, let's say if R1 had all of these subnets, all of them connected to it, let's say different LAN interfaces, fast Ethernet, gigabit Ethernet interfaces, loopbacks, whatever they are. When R1 advertises these networks, to only advertise a summary of the network. So it advertises only 172.16.0.0/16. Why? Because 172 by default is what? That's a class B. So it will summarize all the way back to the default classful boundary, which is 255.255.0.0. Now, and this is basically, if you have a look at the packet tracer example here, let's say R3, if I do show IP route on R3, and this is with default summarization enabled, notice that R3 says I can reach 172.16.0.0/16 via two paths, either via 10.5 or 10.9 neighbor. Now, if I look at the 10.5, means R3 says I can either go via this neighbor 10.9 or via this neighbor 10.5 to reach this network or this network or even this network, the WAN connection. It looks at all of them as the same. It doesn't differentiate that they're actually three separate. This LAN and this LAN and this one. They're three separate networks. It thinks they're all the same. Why? Because R1, it automatically summarized this network to the default boundary. Now, if I look at the EIGRP configuration, show run. Let's say show run. Notice in my EIGRP configuration here, I have auto summary. That's the default for EIGRP to always auto summarize. And if I look at the command show IP protocols, it will confirm this. It says my EIGRP protocol with those K values. Remember the K values? These are the K values. And this is my autonomous system 1. the maximum variance. Variance, remember, this is what I talk about load balancing. This is the parameter we need to change, the maximum number of paths. If it is for unequal load balancing, not equal load, for unequal load balancing. With equal load, we can change it to the another parameter, not the variance. It's called the maximum path. And I think I mentioned earlier 16 is actually 32. Yeah. It's up to 32, actually, not even 16. But let's have a look. Let's have a look here. This point. Automatic network summarization is in effect or enabled. You may see it sometimes called enabled instead of in effect. This is default operation. It says, and I'm summarizing for this network and for this network. I'm summarizing. And it's interesting, yeah? Because here summarization is going to cause me a problem. Because if someone on R3 wants to get to this PC, which is 172.16.1.10, it thinks all I need to do just send it to 172.16.0.0. So it's going to send, and it says I have 2 paths to reach it. So it's going to send 1 ping packet, let's say, out of 001, and it's going to arrive at R2 and to this PC. And this PC will drop it because it says my IP address is not 172.16.1.10, I am 172.16.2.10. But this router thought that this network is also the same network as this one. Yeah. The next packet is going to send via its own serial interface to S001 on R1, which is the 10.5 neighbor. And this packet actually will reach its correct destination because the destination was 172.16.1.10, and this is here 172.16.1.10, so it's fine. Then the next packet will go back here because it's load balancing. And this is what we see from here. It says, I am load balancing. It says, in order to reach this network, I have 2 paths, either via this neighbor or this neighbor. And that's a problem. This is going to be a problem. Sorry? Not in traffic. Half of your packets will be lost. So if you're, for example, if you're sending a Word document over the network, half of the Word document will reach its destination and the other half will be lost because you'll be sending it to another destination. It will go here to PC2, and PC2 says, oh, this is not for me. When it looks at the destination IP address being 172.16.1.10, it says, I'm 2.10. So it's going to drop it. So your file will arrive corrupted at PC1. Will arrive corrupted. Half of the data will be lost. This is a bad example of load balancing. Sometimes load balancing is good. When we have 2 ISPs and want to load balance between 2 ISPs to reach a destination. But load balancing here is bad. It's causing a problem. And how did we get load balancing? Because of the automatic summarization that is the default operation of EIGRP. So what do we need to do as a solution? We need to do no auto summary. So let's go back here now. And now if I change the behavior here to no auto summary, right? And I go back to R2 and I say also no auto summary. Now, if I go back to 3, before changing on R3, let's just have a look, see what happened on R3. Remember here, it was showing only a summary. We did not see the actual subnet. 1.0 and 2.0 were not shown. We only had a summary, which was advertised by both R1 and R2 to R3. So let's have a look. Has it changed now? Ah, it says yes. Now I have 1, 2, and 3, which is this, this, and this. These 3 now are showing separately into the routing table for R3.
If you do it like in 1 or 2, show auto summary, will it show you all 3 or?
Here, R1? You mean do show IP route here? Of course it will show all of them because these are directly connected to R1. It will always show the .1, .2 because they're directly connected. See, they did not learn it from anybody. It's only when you're learning routes via an EIGRP or RIP version 2 or OSPF by routing, dynamic routing protocol, then you have to be concerned about this summarization. Whereas on your local router, you can have as many subnets as you want and they will correctly be displayed in your routing table because they're directly connected. Yeah? But a good question. Okay. So let's go back to, let's have a look at the routing table of now R1 again. Now notice we have 192.168. Where is it? 192.168 1.0, and the 10.0. Okay, now for this, there is no problem because can you see that's also it's showing via D10.8 and a directly connected because it's directly connected. If they were not directly connected, I would also have a problem because I disabled summarization or I enabled summarization on 3. If I disable summarization on 3, and this is how we should do it also on, oh, so I'm looking at 1, yeah, I'm looking at 1. This is how it should be. And these are the networks for 3, 10.8 and the 10.4, which is shared with 3. And this is the 1.0 network here, which is on R3. That's the 1.0 network. But because 1.0, this is the default subnet mask because 192 is a class C. So it is actually summarizing, but it is summarizing to the /24. But we have /24, so there is no conflict here. That's why for the networks, for this particular network on R3, R1 and R2, R1 and R2 have no problem reaching R3's LAN correctly because this is already /24. But if this was, let's say, /27, it will summarize back to 24.
Then you have to do.
Yeah. Anyway, we'll still do the auto summary. So router EIGRP 1, oops, 1, and then auto summary. Okay. Oh yeah. So let's have a look at the routing table again. Okay, nothing much has changed, really. Nothing has changed because this problem did not exist for R3 because R3 was already using for 1.0 the correct subnet mask. Okay, so anyway, so let's go back now and see what we can do sometimes to force summarization manually. Okay. So so now let's go back and say, is automatic summarization enabled? We saw that before when it says it was enabled. And we saw this, the routing table. This is what we displayed. We had two destinations to 172.16.0.0. This one, it was enabled before we disabled summarization. Right, what about summarization? Sometimes you do want to summarize, as I said. If you have 20 subnets, 10 subnets, 5 subnets, and you want to send them to your neighbor, if you don't summarize, your neighbor will have 21 entry in this routing table for every network you have, for every subnet. And you'll end up with a very large size routing table. And the larger the size of the routing table, it means you need more RAM, memory to store it in RAM, because routing tables and ARP cache, they're stored in RAM. So you need a bigger RAM. Bigger RAM means more money, more cost for your router. Also means when you're searching the routing table, when a packet comes in, when you're trying to find the destination based on the routing table, if it's large, it will take you longer to go through the routing table, so it will cause delays as well in your communication. Therefore, sometimes we want to summarize networks to reduce the size of the routing table, and this will result in more efficient communication process. Right, and this situation here, the automatic summarization describes the routing loops that we just discussed. If you have summary routes in the wrong place, but anyway, let's go through this here. The null route. Remember, the null route is created whenever you have more than one subnet. There is always a null route here. Which one is this? Is R3. Okay, let's go to R3. I'll just show you before I continue. I want to show you the null route. Show IP route. Right, for this network. Right, it's not, okay. Let's just maximize this a bit. Okay. Oh, because I removed the auto summary. I mean, I put no auto summary. But when we had summarization, sorry, yeah, I should have showed you this before I removed it. There was a null root. There was a summarized address. The summary address, the 172.16.00 address, was actually pointing to null. And this is what's showing it. Oh, yeah. Perhaps before we changed it. There. Yeah. It is summarizing this, the 10.00. It's a summary root of the 10.0.4, the .632, and the .8. Okay, summarizing it to the null zero. This will only exist. This will only exist if you have what? If you have the auto summary enabled, to automatically create this. And there's a condition that all of the subnets must also exist. If those subnets, the 10.4 subnet, 10.8 subnet, they disappear, this null will automatically disappear. This summary root will, because it only exists if one of its subnets exists as well. Okay. Let's go back here. So we've done the auto summarization, we've done this. But what if you want to do manual summarization? In this example, we want to summarize all of the LANs connected to the R3 router, all of the 192.168. And because EIGRP is a classless routing protocol, we can actually summarize beyond the classful boundary. It means for 192, what is the normal subnet mask for 192? Classful subnet mask. 24/24, the prefix, yeah? If I go less than 24, can I go less than 24? If I go more than 24, I'm doing subnetting. 25, 26, I'm subnetting this net. What if I go 23, 22, 20? What am I doing? I'm summarizing. What I'm summarizing less than the classful boundary. We are set to create a supernet route. A supernet is the opposite of subnetting. Subnetting, I take a network and create smaller subnets by increasing the subnet mask. The subnet mask goes from 24, 25, 26. I'm increasing the subnet mask. I'm increasing the prefix. I'm going to the right. I'm borrowing bits from the host to create subnets. This is subnetting. Supernetting, I'm not borrowing. I'm lending. I'm giving the host some of the network bits. This is the opposite. Supernetting is only possible with classless routing protocols such as EIGRP, such as OSPF, such as RIP version 2. It's not possible with RIP version 1, supernetting. You cannot go back beyond less than the subnet mask. So in here, I'm saying I wanna summarize 192.168, 1.0, 2.0, 3.0. Instead of, we're just making an assumption. Here I only have 1.0. But what if I had also another LAN, 2.0, I had 3.0, all connected to R3. With no auto summary, all of them, if I go to R2 and R1, I will see an entry for each one of them, a separate entry. This will increase the size of routing table for R1, R2. Instead, it says let us manually summarize. So we write the common part, 192 is common. I don't really need to write it out in binary, the 192 and the 168. I don't need to do it because it's the same. Because the rule about manual summarization, we need to start from the parts. We only need to concentrate on where the octets are different in value. And this is from the third octet. The first octet is all 192. The second octet is all 168. The third octet, let us concentrate on the third octet, which is the 1, 2, and 3 value. Here, this is the 1, all zeros 1. The 2 is 0, 0, 0, 1, 0. And the 3, this is similar to the example I did on the board last class. All zeros 1, 1. Notice, this is all the same. This is all the same. And then the first 6 bits is the same. It's common amongst all 3 network addresses. So we draw like an imaginary borderline, separating the common bits from where it starts changing, because this is 0, 1, 1. So sometimes it's 0, sometimes it's 1. So we cannot, it's not the same. So we need to draw this line here. Now, so what is our address now? Our new summary address. Our new summary address will be we add this one, the 128 plus 64, which is also 192. So we have 192 here. And this is 10101000, which is 168, which is 168. Then we come here, 0 plus 0 plus 0 plus 0 plus 0. It's all zeros. So it's 0. And this was already a 0. We bring it here. But what is the subnet mask? The subnet mask, now we need, subnet mask always tells us what? Tells us how many bits belong to the network. That's the whole idea. How many bits belong to the network. And this will give us the number of ones. So how many ones we have in the subnet mask? We have, this is all network. So this is all, so we had 8 ones plus another 8 ones, 16 ones. And this also belongs to the network. We have 6. 6 plus 16, we have 22 matching bits, or 22. The prefix is 22. So /22 is my new prefix, which translates into a subnet mask 255, 255, 252. Now, if I do this, let's have a look. It says, now if I go to R1 and R2 and I do show IP route, I will not see 192.168.1.0 anymore. I will not see it. What will I see? I will see only the summary. Can I prove that? Let's have a look. This is R3. This is R3, yeah? So, conf T. Now, this summary route, I need to advertise it to my neighbors, correct? So R3 need to advertise it to R2 and R1. To advertise to R1, it needs to send the summary out of 0001. Sorry, 000. And to R2 via 0001. So the summary address, I need to create it where? On the inside the interface. So interface is 000. And it says IP, summary address, EIGRP 1. I have to tell it which autonomous system. And it's 192.168.0.0. 255.255.252.0. Okay, now I'm sending this to where? It's going to go to R1. Now I need to also tell R2 this. So I need to go to 001, and the same summary address, I will send it out of this interface towards R2. Let's have a look. Show IP route. This is on R3 itself. On R3 itself. Has it made any difference to R3? No. R3 is still, because those networks are all directly connected. The 1.0 is directly connected, so it will show exactly as it is. However, let's have a look here now on R1 and see what happened on R1 and R2. Sure. Ah, it's disappeared. 1.0 disappeared. Now we have 168.0.0/22. So I'm only seeing the summary now. The actual subnet, if I go back up here, it should be there somewhere. There. I had 1.0 here. See that? 1.0. Now this is being replaced by the summary routes. By the summary route. And similarly, if I go to R2, I will see also something similar. There you go. I don't see the 1.0 anymore. I see the 0.0. You see that? So we've done manual summarization. Okay, now we've talked about this last time, the default route to the ISP, and we said the way we redistribute this using the command redistribute static. This is what we did on the ISP, on our edge router R2, on edge router R2. So on R2, if I go back again and do show run, just to say this is what we did last time as well. We covered this already. So notice we said redistribute static. What is it going to distribute? Not thin air. It's going to redistribute this default route we created, which will take us to the internet. R2 is our edge router, which is connects to the ISP, which is the internet. So this default route says any network I don't know about, any network which is not present in my routing table, because the routing table is limited, yeah? This is my routing table. I only know about these networks, only these networks. I don't know about the rest of the networks. There are millions and millions of networks in the world on the internet. How can I reach them? I will reach them with this special static route I call the default route. but I want, this is only good for me. R1 and R3 have no idea of it unless I tell them, come to me if you want to reach the internet. And I do this by typing this command. So run. Under my EIGRP process, I said, under my EIGRP, I want you to take this route and redistribute it to all of my EIGRP neighbors. Why did I say static? Because this default route is actually a static route. It's a special case of a static route. It's a special case, but still it's a static route, yeah? And this is what's happening here. Okay, and notice the other routers, when they receive it, one, they received it via EIGRP, so it's a D. There's a star because it's a default route. It's an EX because it's external, it came from a static. And the admin distance is 170 to differentiate it from, this is the admin distance 170, differentiate from the 90, which is the administrative distance for the internal EIGRP routes. Internal EIGRP routes. Hello and hold time timers. Remember we said the hellos, depending on your network speed. If it's a fast network, which is a multi-access broadcast networks, which is a T1 or faster, then every 5 seconds you send the hellos. If it is a non-broadcast multi-access network of equal to a T1 or less, such as a frame relay, ATM, of a T1 speed or less, then the hello is every 60 seconds. Now, if I don't receive a hello up to 3 times the hello interval, I say this neighbor is down. So 3 times 5 is what? 15. 3 times 60 is 180. Now, these are the default. What if I want to change them? Can I change them? Yes, you can, using the IP hello interval command, EIGRP 1, I have to tell it which autonomous system, 1, and then 60. Let's say someone changed it, and I want to put it back the way it was. Or I can put, instead of 60, I make it 50, or make it 70. Be careful. If you change it from 60 to 50, the hold time timer will remain at 180. Doesn't automatically change to 3 times that. You have to manually change both of them. It is not recommended. It is not recommended that you change the hello timers.
If you increase it,
basically, then there may be delays. If you lose a neighbor, the neighbor is not there, then it will take longer for you to detect the neighbor is down. It's best to leave it as it is, unless you're told in the exam to change it, so just to test your your knowledge. Okay. Now, what if the timers are different? Like one router has the timer 60, and the other router, the hello timer is 50. Will that cause a problem? Will they still become neighbors? The answer is yes. For EIGRP, the time is not a condition. They don't have to match. For OSPF, when we come to OSPF, inshallah next week, we'll see that it does matter for OSPF. The timers must be the same for all routers, because also OSPF has hello timer and also a dead interval timer. But they have to be the same. Here, they don't have to be the same, but it's not a good idea to change it because unexpected results may happen if one has a slower timer than the other one. Okay. Here, remember we said we can load balance by default up to 4, but you can change it up to 32 by using the maximum path. So you go inside the EIGRP router command, and you take maximum path, and you say 5, 6, 10, up to 32 you can have. By default, this is 4. Right? 33 is 4. Okay. And this is load balancing on IP version. So just for information, this is how it looks. Just as an IP version 6 address. This is a network address, by the way, the 2001. This is a network address destination. Notice the admin distance is still 90 for EIGRP, and this is 41 million, which is the feasible distance, yeah? And it says I can get to this network, to this IP version 6 network via this neighbor with this link local address, or this neighbor's link local address. Link local address is the same as my, what we call the next hop address, yeah? No, so no, this is an IP address. It's all IP. But when IP version 6, remember, IP version 6, there's all uses hexadecimal. Now, authentication, this is the last part I want to talk about. Authentication, you need to know this for your theory test, okay, and the final exam, the authentication. EIGRP supports only encrypted, secure authentication. using message digest 5. Remember, MD5 is one of those very secure algorithms that you can only encrypt one way. You cannot go back. You cannot go back, yeah? But version 2 also supports MD5, OSPF also supports it, ISIS, and BGP. They all support various MD5 authentication.
But not the same MD5 used in EIGRP, is the same.
Same MD5. Same MD5. There's one MD5 here. And actually, also with RIP, it's very similar when you configure MD5, the authentication RIP version 2, of course, because RIP version 1 does not support authentication. The commands are very similar. For both of them, you say keychain, give it a name. You have a keychain, a car keychain, correct? Now, so you give it a name, call it my chain, whatever. And then inside the keychain, you have keys. Don't you have keys?
Yeah.
You have 1 key, 2 keys, 3 keys. You can have multiple keys. 1 key will open this door, 1 key will open this door, 1 key will open this, yeah? Same thing here. You can have multiple keys. Now in here, we need at least 1 key. And this 1 key, we can share it among all of my routers. So the key ID is key 1, key 2, key 3. Okay, just give a number, 1, 2, 3, okay? And then for this key, every key we have, it has a different shape. Different shape. It's not the same key will open. And in this case, the shape of the key, we represent it with a string. Another name for the string is the password, really. This is the password. We call it the string.
Give it ID and password.
The ID, key 1, and this is your password. Yeah, and this is your password. And then you go to the interface. Authentication has to be set at the interface. So, for example, if I come here to the packet tracer, I need to, if I want to set authentication between R1 and R2 only, R1 and R2, then I come to 000, and I can set the authentication. I apply it to this interface, but I need to apply it on R2 000. Otherwise, if I only apply it on one link, one side of the link, then they will lose connection. Because one of them says, I cannot authenticate you. The other says, what are you talking about? I don't know anything about authentication. So they don't become neighbors anymore. So make sure that on both sides of the link, you have to set exactly the same keys. Okay? Exactly the same. It has to be the same keys and the same key string. Otherwise, they will not authenticate you. Now, if I do it on the link between R1 and R2, do I need to do it on all of the links? No, you don't have to. Each link is independent from the others, but it's a good idea to do it. So you enable it by using the command.
If you do it from R1 to R2, and then you send something from R1, okay, you go through R3 and then R2.
Doesn't matter. Doesn't matter. As long as the link between R1 and R2 is authenticated, because between R2 and R3 there's no authentication, no problem. Yeah. So you put the command IP authentication mode. You have to set which authentication mode you're using, which is MD5. So authentication mode EIGRP, put the AS number like 1, MD5. And then you need to tie it to the keychain. Which keychain you're going to use for this? So say authentication keychain, EIGRP, autonomous system number. Okay. Of course, here's the keychain. You have to say which keychain, the keychain name. And there you go. That's an example. So keychain, and we called here EIGRP, and our keychain we called it what? EIGRP underscore key. Okay. Now we've done it on both. On R1, so I've done it on my 000, which connects me to R2, and on my 001, which connects me to R3. So I need to do the same now on R2 and R3. Otherwise, I cannot talk to them now. Yeah. So keychain, I need to go to R1. Okay. Let's. You have time? Yes, quickly. Let's configure this. So let's do it at least on one link. Yeah. You have time, perhaps on one link. Okay. Right. So interface. So conf t. Let's do it for Let's do it for R1 serial 001. Okay. So keychain EIGRP underscore key. It's not. Oh dear, it's not supported. It's not supported. Beg your pardon. There is no command key. K. All right. Okay, so we cannot do. I'm pretty sure it was supported.
لا يعني ما يستوي هذا جديد
آخر مرة بعد ما وصلنا
Okay, we're gonna do it in the lab. Do it on the real equipment. Verification authentication, show IP IGRP neighbors to show that you still have your neighbors. By the way, this is very important command. We didn't actually use it very much so far. So show IP EIGRP. This is very important troubleshooting commands when you're doing labs and exams. Notice R2 says I have two neighbors. I have two neighbors, 172.31 and 192.168.10.10.
أستاذ هذا سويناه على الراوتر طلع لنا مثلا مال احيانا سويت من الراوتر 2 صح؟
This is R2, yeah. So let's have a look. This is R2. It's saying, let me just put some note here so that we know the IP address for 001 is 172.16.3.1. This is 000's IP address. This one here is 3.2. Okay, and R3 is 1. This is 6 and 10. 6 and 10. So here, this is 192.168.10.10. And this one here is .6. This one here is .5. And this one here is .9. Okay, so we can see what's happening here now better. So R2, let me just make this smaller here. Can you see it?
Yeah.
Okay, so it says R2 has one neighbor 172.16.3.1, which is this neighbor, and the other neighbor 192.168.10.10, which is this neighbor 10.10.
Oh.
It has this neighbor, has two neighbors. Now if I go to R3, sorry, if I go to R3, okay, you lost your laptop? Okay, class, show IP EIGRP neighbors. Now R3, see what R3 says. I have neighbor 10.5, which is this one. This is 10.5, and 10.9, which is R2. Can you see that? So each of them have two neighbors. Now this gives me only a summary. If I want, I can also. Oh, there's no detail. Oh, there's no detail option. On the real equipment, you can actually put neighbor detail, where it gives you even more details of the neighbors. Okay, so this is your application. So show IP IGRP neighbors. Very important, guys. These commands, make them your friends. Show IP route, show IP protocols, show run. For EIGRP, show IP IGRP protocols. Make them these commands. Notice for IP version 6, the only difference between the commands, instead of whatev there is IP, put IPv6, IPv6. Otherwise, the commands are the same also for IP version 6. Okay? Right, I think probably show IP interface brief, and then another command to make sure that you have connected. Otherwise, if you say, you do show IP IGRP neighbors, no neighbors. Why? Do show IP interface brief. If it tells you one of the interface is down, could be shut down, you forgot to do a no shutdown, this is a very good troubleshooting tool. Ping, trace route are very important connectivity. Show IP protocols, very important. Okay, so passive interface, we talked about it. Some errors that can go, make sure you have added a network statement for all your directly connected networks. Sometimes you miss a network, and then you said, why can't I reach it? Because you didn't advertise it. Okay, so these are some common troubleshooting techniques. When we finish chapter 5, this is very good for today. Okay, so thank you very much, gentlemen. Okay, and please work on your design, on your project. Okay, and so that next week we can start on OSPF.